Hello guys, this is Samadhan Kale and welcome to all of you on my YouTube channel. So in this video guys, we will learn the linear algebra. Okay, so we have started this linear algebra course and in this video we will learn about the basic methods, how to construct the matrix and matrix constructors and then function of the matrix and vector operations. Okay, so this is the concept overview of the video. So guys, before that, those of you do not subscribe to my channel, please subscribe it and press the bell icon so that you will get the latest update of videos like of this. Okay, so let's start the today's video. So firstly, we will see the basic methods. Okay, so basic methods. So there are so many methods. So we will see how we can use the basic methods on matrices. Okay. Now I will take the today's matrix as A is equal to, I have imported the sympy library first. Okay. So it is known as sy. Okay. Sympy as sy. So sy dot, I will use the matrix function. Okay. Matrix. And now I will take the 3 by 3 matrix. 3 by 3 matrix. Suppose I will take 1, 9 and minus 1. Okay. This is my first row. Second row I'm going to take 3, then 4 and then minus 2. Okay, this is my second row. And third one is I want to take 0, then minus 2 and 1. Okay, so this is my first matrix A and I'm going to print this matrix A. Okay, so this is my first matrix. Now I will take the second matrix. Okay, B is equal to is sy dot matrix. Okay, and I'm going to take, now the matrix is 0, 1, 2 is my first row, and second row I'm going to take 8, 5 and minus 6. Okay, and then I will take the third row as this 2, then minus 2 and 1. Okay, minus 2 and 1. I have to give the double bracket. Okay, yes. So this is my second matrix B and I will run this. So these are the two matrices guys. Now I will perform some basic operations on it. Okay. Now if I want to take the addition of these two matrices. Okay. So simply I will take A plus B. A plus B. Okay guys. So it will add the component wise element of these two matrices A and B and I will get a simplified matrix that is A plus B. Okay. Now if I want to take the multiplication of these two matrices, so I will use A star B. Okay. A star B. So basic Python's operations we have to take here. A star B if I take, so I will get the multiplication of these two matrices. Multiplication of these two matrices. So this is the A star B. Now, if I want to take A minus B, that means subtraction of these two. Suppose I want to take B minus A. Okay, so I will take B minus A. So I will get a simplified matrix that is B minus A. Let's see, guys. It's a very interesting and very simplified form. Now, suppose I want to take the power of matrix. I want to take a power of matrix. So the for power in Python we take the double star operator. Okay. Suppose I want to find the matrix is, okay, the matrix is third power. Okay, that means I want to find the A cube. So this is the A cube guys. Okay, instead of 3 I can use 80 also. If I want to find the matrix power 80, so this is the 80th power of the matrix A guys. Okay, so this is the thing. If I want to find the 8th power, I can find the 8th power. Now, if I want to find minus power, so I can find it. Okay, so A double star minus 1. Okay, A double star minus 1. If I run this, so I will get this A raised to power minus 1. That means 1 upon A. Yes, 1 upon a. So this is the a raised to power minus 1. Now, if I want to multiply by a scalar to some matrix, okay, suppose I want to multiply matrix A by scalar 2. So I can take 2 into A, okay, 2 into A. So this is the basic operation. If I want to take, I want to multiply the matrix B by minus 1, okay. So B into, I will write as minus 1, okay. So it will give me this output. That means the matrix B is multiplied by minus 1. So these are the basic concepts, guys. That are the basic method and basic operators. Okay. Now we will take the matrix constructors. Okay. Matrix constructors. So how we can construct some specific matrices. Okay. So matrix constructor, and let's run it. Okay. So the first one is identity matrix. Okay. So for identity matrix, all of we know identity matrix is a square matrix. Okay. So it is a square matrix. That means the number of rows and number of columns in this matrix are same. Okay. So in this library, sympy library, there is a I function for the identity matrix. Okay. Suppose I will give this I for identity matrix. Okay. I for identity matrix, and that is equal to sy dot I. Okay. This I means identity matrix. If I want to take 3 cross 3 identity matrix, so I can take it and I will print this I. Okay, let's run it. So I will get a 3 by 3 identity matrix. Okay, so if I want to take identity matrix of 4 by 4, okay, so I can take sy dot I 4, I 4, and then this I. So I will get the identity matrix of order 4. So this is the construction of identity matrix. Now, if I want to construct a zero matrix, if I want to construct a zero matrix, so how I can construct it? Okay. Now for this zero, I will give the z for zero matrix. Okay. So z is equal to this sy dot zeros. Okay. Sy dot zeros. And now here you can construct any order matrix. That means 2 by 3, 3 by 2, 4 by 5, 4 by 4, any order of the matrix. Okay. Suppose I want to take 3 cross 2 matrix and whose all entries are 0. Okay. So if I run this, so I will get uh, 3 rows and 2 columns here. 3 rows and 2 columns, and all entries of this matrix Z are 0 entries. Okay. So similarly, if I take the 4 by 4 matrix of all entries 0, 4 by 4 matrix and whose all entries are 0, so I will give 4 comma 4 in the zeros function. So I will get a 4 by 4 0 matrix. Okay. Now, if I want to take the matrix whose in all entries are ones, whose all entries are ones. So there is a ones function. There is a ones function. By using that one function, we can construct a matrix whose all entries are 1, and that matrix is of any order. Okay, the same thing. So for 1, I will give the O is equal to sy dot, I will use the function ones. There is a ones function. Okay, now I want to construct a 2 by 2 matrix and whose all entries are 1. Okay, so I will get a 2 by 2 matrix and whose all entries are 1. Now I will copy the same code, and now I want a matrix whose all entries are 1 and it is of order 5 by 6. Okay, so I can take this 5 and 6 in the ones function. So I will get a 5 rows and 6 column in this matrix and whose all entries are 1. Okay guys, I hope all of you understood how to matrix construct. Okay, now how to construct a diagonal matrix. Okay, how to construct a diagonal matrix. So for diagonal matrix, I will use this as a T. D is equal to, there is a diagonal diag function. By using that diag function, we can construct a diagonal. Okay. So D is equal to, I will use this sympy library sy dot this diag function. Okay. Diagonal of, if we take shift tab, then you have to give the values, strict, unpack, and keywords. Okay. So here you have to give the value. Suppose you want to take the diagonal of this, 1 second, it's not this one. Okay. Here I have to take this code. Now sy dot diagonal of, I want to take 1, 2, and 3, and then I will take this D as it is, D as it is. So if I run this cell, I will get a diagonal matrix of these 3 entries, guys. Okay. So 1, 2, and 3. These 1, 2, 3, 1, 2, and 3 are on the diagonal elements. Okay. So this is the construction of diagonal matrix. Suppose you want to construct a diagonal matrix of order 5 cross 5. So you can construct it. So D5, I will use as D5 is equal to this sy dot diagonal diag of, you want to take 5 cross 5, 1, 2, 3, 4, and 5. Okay. So you can give these entries at the diagonal. So I will write as D5, then I will get the matrix D5. Let us see, this is the diagonal matrix of order 5 cross 5. Okay, now we will move ahead. Now I will define some function, okay, by using the lambda function, and I will perform operation on it. Okay, suppose I will take f is equal to the function, that is a lambda. Yes, f is equal to lambda function, and I will write as x. Okay, and then colon, I will write 2 into x. How to take the function 2x function? It is the defining way of the lambda function. Okay, now I will take sy dot identity matrix of order 3. Sy dot identity matrix of order 3, and I will apply the function f on it. Okay, so dot this apply function yup. Okay, apply function yup, and if I run this, so what I will get, guys, let us see. That means we have defined this yup lambda function 2 into x. Okay, and in this function we have applied identity matrix. We have defined this identity matrix of order 3. So it will apply this 2 star x. That means 2x will be applied on this identity matrix. Okay, that means this 2 is multiplied to the matrix I. Yes, so this is the very easy way to defining the function also. Now if I want to take a matrix in symbols, that means in matrix there are some constants. Okay, so how we can construct the constants in matrix? Okay, constant matrix, how we can construct a constant matrix? So for that I have to give the variable. Okay, x is equal to sy dot symbol function. Okay, sy dot symbol, I will define this symbol and give this symbol as x. Okay, I want to take the parameter or the variable x in this one. Now I will give the name of the matrix as m is equal to, okay, this sy dot identity matrix of order 3 or 4. Okay, and into x, into x I am giving this, and I will print lastly the matrix M. And if I run this, so I will get a diagonal matrix of order 4, and whose diagonal elements are x, 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 and x. Okay, so this is the thing. Now in this matrix M, if I want to take, I have defined the matrix A. Okay, so if I take A minus, okay, this A minus this matrix M, then what I will get, guys? See, so it will give me error, because this is the 1 to 4 cross 4 matrix, and that is the 3 cross 3. Suppose I will take here 3, then it will take the 3 by 3 matrix, and now it will give me this matrix, that is subtracted. Yes, 1 minus x, 9 minus 1, and this is the matrix. Yes, so I can perform the operation on this matrix also. Now if I want to take, instead of this x, I want to take some number in this matrix m. So how I can get this number? So there is a substitute method. By using that substitute method, we can substitute the value of x. Okay, substitute this x replaced by number. You have to give any number. Okay, so how we can substitute? Let us see. So where you have to substitute in a matrix m. So m dot, you can use this substitute function subs. Okay, substitute. Instead of x, I want to substitute 4. Instead of x, I want to substitute 4, and then I will run it. So this x is replaced by 4, and if I take a minus m, then again I will get this one. Okay, now this is the thing. Now we will see the vector operations, how we can operate our vectors. So vector operation, vector operation. Yes, so I will convert it to markdown and run it. So see guys, there are two operations, dot product and cross product. So how we can take the dot product of two vectors and cross product of two vectors? By using the sympy library. Okay, now I will give this vector v1 as sy dot matrix. Okay, in the matrix I am defining the vector. Okay, so single vector, that means we have to give only one square bracket, 1 2 3. Okay guys, this 1 2 3 means I plus 2j plus 3k. Okay, so I will take the v1 and I run this. So I will get the v1 vector. Now I will take the v2 vector. V2 is equal to sy dot matrix. Yes, matrix, and I am going to take this minus 4 and then 2 and 1. Okay, and I will print the matrix or this vector v2. Okay, v2. Just one second, is v2, v is a small, not capital. So this is the v2 vector guys. Now I want to perform dot product of these two vectors. I want to perform a dot product of these two vectors. So how I can perform? So v1 dot, I will use v1 dot, you have to give the dot function. Okay, dot with v2, v1 dot v2, and then run it. So you will get the dot product of these two vectors, dot product of these two vectors. Okay, and if I want to take the cross product of these two vectors, so I will use v1 dot cross function. Okay, cross with v2, cross with v2, and if I run this, so I will get the cross product of these two vectors. Okay, v1 and v2, it is the cross product and it is the dot product. So remember that guys, the dot product of two vectors is a scalar and a cross product of two vectors is again a vector. So this is the thing. Now if I take the v2 dot v1 cross, okay, v2 dot cross product with v1, reverse, I will change the direction, then what will happen? See, it will take the negative only. Okay, that means if we take v1 dot, sorry, v1 cross v2, then we will get minus 4 minus 13 and 10, and if we take v2 cross v1, then 4 13 and minus 10, that means the signs are get changed only. Okay, and if I reverse the dot product again, so v2 dot of v1, v2 dot of v1, then what will happen guys? See, it will give me only 3. Okay, in the dot product there is no change, but in the cross product there is change. Okay guys, now I will see, I will take some operations on the matrices again, and I will find the transpose of matrix. How to find the transpose of matrix? Now, if I want to find A, okay, I will give the matrix A, so that yes, this is our matrix A. Now, I want to find the transpose of this matrix A. So I will use A dot T function. A dot T function. That means it will give me the transpose of matrix A. That means the first row becomes the first column, second row becomes the second column. That is A dot T means the transpose of matrix A. Okay. Now, if I want to perform the operation like this, okay, I want to perform the operation like this. Okay. So A square, I want to perform A square plus 5 times b, okay, 5 times b minus I want to take the m, okay, and plus again I will use 3 times a. Yes, so this is the operation that I have to perform. So what I will take, I will take this a as it is, okay, then I have to give the square, that means a square, then I will use the plus, then I will use the 5 and b, then plus, sorry, minus the matrix M that we have defined already, then 3 and then star A. Okay, 3 star A. Here I have to give the 3. Yes, 3 star A, and here 5 into B means 5 star B. Okay, now I will give the brackets for this so that it will understood very fastly and easily. So where and what is the operation is there. Okay, so this is the thing. Is minus m and then 3 star A is there. Okay, and if I run this, so I will get this matrix. Okay, now suppose I will cut this m, that means in m there is x included, then what will happen? Let's see. I will get the matrix. That means we can perform any operations on the matrix, guys. Okay. There are so many interesting things in the linear algebra. In the upcoming videos, we will see that interesting things. Okay, guys. Thank you for watching the video.